Hello, and welcome to the review of the upcoming Compute Ontario Summer School. My name is Paweł Pomorski. I am based at the University of Waterloo, and I work for Sharcnet, Compute Ontario, and the Digital Research Alliance of Canada. So first, let's just focus on the essentials. Our upcoming summer school, it will run from June 3rd until June 21st, so 3 weeks. The courses take place, sessions take place daily, Monday to Friday, from 9 a.m. until 4:30 p.m. There's a morning and afternoon session with a 90-minute break for lunch. This is offered online via Zoom and Moodle. So there's no physical location where you have to be to take this. You can just be anywhere in the world. Registration is open. Anyone can register. The website for the registration is given there. We still don't have it completely up and running. We have a preview version, but we are going to have the full version shortly. And registration opens on Monday, May the 13th at 2 p.m. So these are the essentials, and let's now get into the specifics. So the history of summer school. This is an annual event which has been offered in various formats since 2002. And if you are interested in the Sharcnet's contribution to that history, there's the link that you can click there. Initially, these were in-person events. So we would pick, we at Sharcnet would pick one of the universities or colleges which are under us, and we would physically go there for about a week and have a very intense, few days of work. But in 2020, we could not do this anymore because COVID came. But this gave us interesting new opportunities because we started offering this summer school online, and we found that this works much better for many of our users because our user base is very spread out all over Ontario, all over Canada, and it's difficult to physically come to one location to take courses. So now this is offered online. And another opportunity was to join together the summer schools, which used to be separate. The summer school of SciNet at the University of Toronto was separate from the Sharcnet summer school, and CAC in Kingston, Ottawa offered their own. Of course, we had some instructors moving back and forth between the summer schools, but these were 3 separate events. But since about 2020, there's one unified event, which has some advantages in that we can offer more courses, even some niche courses which might have too few people in 3 different summer schools might have enough people in one main summer school. By the way, if you are impatient and you would like to see the summer school website, we do have last year's summer school website. So it's the same link as this year's, just the number is different. And you can see that the list of courses there. Of course, the courses are different this year. Some of them remain the same, but some are different. But nevertheless, you can look at that website if you want to see what we did last year. Now, next, accounts. So any person that registers for summer school can be issued a guest account. However, we strongly encourage you to use an alliance account. So if you have one already, that's excellent. If you don't have one yet, you can get one. If you are a researcher, a graduate student, a postdoc, a professor at the Canadian University of College. So the advantage of using an alliance account is, a summer school account is temporary. Once the summer school is over, you lose the account, whereas the alliance account, you keep it as long as you're working at the Canadian Research Institution. So it's very beneficial with an alliance account, you can just continue whatever work you did at summer school in the future. You don't have to lose your work. But also very specifically, a few courses do require an alliance account, and this has to do with the kind of hardware that you will need access to. So all of our clusters, they have implemented multi-factor authentication just this year, and this prevents us from issuing guest accounts which allow access to clusters because of the MFA requirement just makes it too complicated. So our guest accounts will actually have access to a virtual cluster, but some of the courses, specifically those using GPUs, we found that they don't function as well as we would like on virtual GPUs on the cloud. So for those, we are going to be using reservations on our clusters, but to get into those reservations, you need to log into the cluster and you need an Alliance account. So these accounts are free to all Canadian university researchers. And if you're a student, you will need your supervisor to obtain an account and to sponsor you. So there's this step that you will need your supervisor to be in the loop. So this is why if we encourage you to get this done as soon as possible, just to complete all those steps. And here's a link for the registration. But if this link is too long, then you can go to our Alliance documentation wiki and just get all the information from there. But these slides will also be posted on the YouTube channel after this presentation. So we are recording this. This will go on our YouTube channel, and you can get them from there if you need this exact link. So again, to keep things short, try to have an Alliance account before summer school starts. It will be beneficial for all courses. So registration, as I mentioned, this will be open on Monday at 2 p.m. It is first come, first serve. So our courses, they do have a class size limit. The default is 250, and this just has to do with how many people we can have in one Zoom session at once. But some courses have a lower limit if there's some hardware limitations. For example, GPU courses, we have a limited number of GPUs, so the limit there is 100 students. So if you want, some courses are very popular. So if you want to make sure you have your place in them, you should register as soon as you can. Keep in mind, though, that we are offering courses in 2 streams. So there's 2 parallel sessions going on at any one time. So it's your responsibility to make sure that you don't register for 2 courses that overlap. So just, within a given day, you can just register for 1 course. And let me also stress, it's very important that if you register and then you find you cannot attend, please unregister to free up space for other students. Also, it's just makes our organization very much easier if we know how many people to expect in the course. So yes, so there's no cost for registering. So it's easy to click the button and to register, but just remember, if you cannot make it, then please unregister. So the hardware available for summer school. So we very much like to emphasize for most of our courses, except a few short ones, which are just presentations basically. But for longer courses, we always have a tradition of students doing hands-on work. So you will actually get access to a real parallel computing, high performance computing system for your activities, and there will be time for these activities. So for sort of conventional parallel computing, we are going to be offering a virtual CPU cluster, which is created via software called Magic Castle. And this is a full supercomputing cluster with a scheduler, a login node, compute nodes, and so on. But it's created temporarily in the cloud. But what this allows us to do is it allows us to create temporary accounts which don't require multi-factor authentication, because our main clusters, multi-factor authentication is mandatory. But on this temporary cluster, we can skip that step, which makes logging in easier, of course. But as I mentioned, for a few select courses, specifically courses which are using GPUs, we found that virtual GPUs just don't offer enough performance. And in the courses that we offer, we actually want to show you that if you're using GPUs, your programs will benefit, they will run faster. But to allow that to happen, you need full access to the GPU. And we found that the GPUs on the cloud are not quite up to scratch on this. So this is why we're going to be using clusters on our reservations on our actual clusters. But for this, as I mentioned, you will be required to have an Alliance account. And we will make it very clear on the registration pages which courses do need an Alliance account, so that you are sure, whether you can access the course or not. Let me briefly mention our instructors. We have most of the instructors are from the free supercomputing consortia that form Compute Ontario, so CAC, SciNet, and Sharcnet. But we also have guest instructors from outside these consortia. Let me mention here MathWorks, who will be teaching MATLAB training sessions. So these are the experts who actually, create that software. And we are also going to have some guest university faculty lecturing a few courses. And there will be over 40 instructors in total. Certificates. So students like to, when they attend summer school, many like to have some documents saying that they attended. You can put this on your resume. It doesn't hurt. So we are going to have those. We had them in the past. These will be issued for individual courses. So there's no summer school certificate as a whole. You get a certificate for each course that you attended. So this, of course, means that you don't have to register for all of summer school. You can just register for whichever courses are particularly interesting to you, and these can be as few and as many as you like. But to get the certificate, it's required that you attend the live session. So we are going to be taking attendance during the sessions, and to be considered for a certificate, you have to be there. And for short courses, attendance will be enough. But for some longer courses, we are going to have in-class activities or assignments, which in order to get a certificate, you must be able to complete the assignment satisfactorily. And let me also mention that, so to get the certificate, we do want people to be there live while the course is offered, but we do record these sessions. So, if you have some situation that you have to leave for an hour because of some errand you have to run, we are going to have recordings. So you might not be able to obtain your certificate, but you should be able to get the full benefit of attending the course, if you have to watch the recording. And of course, the recordings are also useful if you want to, let's say the live course is over and you want to review what was covered. You can also watch the recording, which is usually available shortly after later in the day after the course is done. So I'm not guaranteeing here that every course will have a recording. Some instructors might not want to record for whatever reason, but most should. Okay, so let me now talk about the courses being offered. Now, there's many of them, and there's simply not enough time for me to go through every single one in any great detail. So what I decided to do is I will just pick a few of them at random and just say a few words about them. So as you can see, these courses are organized into categories. So there's ARC, which is Advanced Research Computing courses. So this used to be called HPC, but now it's ARC. And this covers what we might consider, traditional high-performance computing. So, programming in parallel languages, using advanced hardware, and so on. And let me also mention that these courses, they vary in length. So the shortest courses we offer this year are 90 minutes long, and the longest course is 3 full days. So here I highlighted in bold longer courses which take at least 1 full day of work. This 1 full day might be spread out between 2 days, so there might be 2 half-a-day sessions. So just the bold highlight just indicates that it's a bigger course than the other ones. So we have, the standard introduction to Linux Shell, introduction to advanced research computing, introduction to Git. Then we have a Python course, both basic introduction to Python if you haven't seen it before, and high performance computing in Python course, which assumes that you already know Python and you want to now run it on a larger parallel computer to benefit from this. We have a course in R programming language. We have introduction to C. We have modern C++ parallel programming. So this is a course which emphasizes the new features in C++, which have to do with parallel programming. We have parallel computing with MATLAB. That's the course taught by the MathWorks experts. Multi-core parallel programming, that covers OpenMP. And GPU programming, so that's programming GPUs with CUDA. So let me highlight this course simply because I am one of the instructors. So I'll take the liberty to say a few words about that course. So I am the instructor together with Sergei Mashenko. We taught this course for a number of years across both at Sharcnet and different summer schools across Ontario. So this is an intense 3 days course where you get the opportunity to do hands-on programming of GPUs using the CUDA programming approach. And we start simply, we assume you don't know anything about GPU, so we just introduce gently, what the GPU is, what's the main idea, which programs can benefit from, using a GPU, and we show you how to write a basic program. And then you proceed to taking a serial program and parallelizing it on the GPU in a kind of a longer exercise. And then finally, we move into more advanced features. How can you really optimize the performance of the GPUs and get the maximum benefit? Okay, moving along, we have a course on SQL, so databases, a course on data security, and then a course on storage. So this is high performance storage systems. This is a very interesting topic if you are using disks on our clusters intensively, and if storage is the limiting factor in your performance. So in this course, you will learn about issues, how to avoid storing millions of tiny files. That's the big issue that we want to help our users with. But you will also learn about the details of our file systems, because it turns out you have some control over how your files are stored, how they are divided into blocks and stripes. And for different kind of storage, you might get some benefit from changing those parameters. So that course will be of interest to those people who really find that the access to storage is the main bottleneck for the research. Then we move on to working with Jupyter on clusters. So this is a short course about using a Jupyter notebook on the clusters, which is possible. And this moves into Introduction to Scalable and Accelerated Data Analytics. So this is a course which is all about using Python libraries like NumPy, Pandas, scikit-learn to analyze your data, but then powering up this analysis by running large data sets on clusters using tools like Dask and Rapids. And Rapids will allow you to offload some work to the GPU actually. So you will benefit from using a GPU to process a large amount of data. We are then going to have scientific visualization, full course, and also a course on using containers, Aptainer specifically. So it is quite common nowadays that some scientific software requires a rather complex software stack with many different packages installed. And while we try hard to install software for users, sometimes the requirements are just too complex. And in that case, it's actually better to create a container where you have exactly the software that you need installed. And also, many scientific tools are actually distributed as containers nowadays. So the way you install it and use it is you download a container. So we work hard to make that possible in our clusters, and we will have a course specifically on that topic. And then we are the last course to mention is leveraging HPC for computational fluid dynamics. So that's a more domain-specific course, specifically to people who are interested in CFD. So these are, so to speak, our traditional summer school, ARC high-performance computing courses. And let's move on to other categories. So machine learning is a big topic. So we have some specific courses for this. So we start with an AI Showcase course. This will be an example where we are going to work through some specific problems. So in this course, you will be walked through AI history for problems like lip sync, video restoration, face aging, and this will be using model and projects from Hugging Face. So this will be an interesting introduction to machine learning. We also have a course on text mining, machine learning with MATLAB, again, taught by MATLAB experts. A course on data preparation, which is actually a prerequisite for the machine learning course. Because if you're trying to do machine learning, the first essential step is to organize your data in a way that can be usefully addressed with machine learning. And this takes a little bit of knowledge and preparation. And the data preparation course will cover this. And then the machine learning course will actually go into the details of machine learning. We also have as kind of a parallel artificial neural network deep learning course. That's also a very long course over multiple days. And finally, we have one more course about image inferencing. Next category is research data management. So, research data management is becoming a bigger and bigger topic, especially when we have people coming in from non-traditional HPC fields like humanities and social sciences. So we have a number of different courses here, although these are generally shorter courses. They are half a day or less. So we have research data management, some introduction to ChatGPT, how that can be used to manage data, using generative AI tools. There's also a session introducing to Alliance RDM services, supporting research with data management plans and pairing up open science with Borealis, academic libraries and machine learning, using Quest for survey and public opinion research, and reproducible research practices and tools. And finally, we have what we call domain courses. So these are courses for a very specific area. So only people in that area would probably be interested in this. And this year we have a focus on bioinformatics. So we have 3 different courses, including one longer course. So let me highlight the last one, bioinformatics, introduction, metagenomics. And in this case, you are going to actually have a workshop where you will go through a full genomics workflow. So sort of from start to end, getting your data and producing a useful outcome.